All right. At the risk of the context being lost on a few people that show up a little late, we'll go ahead and get started. My name is David Bills. I'm a general manager in the Trustworthy Computing Group in the Advanced Research Strategies and Research Division at Microsoft. In TWC, we really focus on all the different attributes that accrue to that notion of trustworthy computing. My particular focus, reliability. Trouble is, reliability is not all that exciting a word. So today you're going to hear me use the F word an awful lot. Failure, folks. Honest failure. What I want to do is to talk a little bit about kind of the journey that we've taken as a company to evolve our thinking around how to approach a particular design practice called failure mode and effects analysis, and the way that we've adapted it for use at Microsoft. So we'll start with this. I thought it was apropos. Anybody here for this? How many of you watched? If you're like me and a 49ers fan, how many think that it changed the outcome of the game? 34 minutes in the dark. What's interesting is that immediately after this occurred, the power company said, "Oh, not us, not us." It's interesting. Let me give you the quote from the management company. They said, "A piece of equipment sensed an abnormality and then threw the breakers, as expected." Do you think they expected it with a stadium full of people, 100 million people watching it, screaming fans? What a mess. The simple fact of the matter is that this system performed as it was designed to. The rub was that the technology that they used took over 15 minutes once they'd restored power for the lights to actually start performing as they should. I doubt that, in hindsight, that the system really designed the way that they expected it. It designed the way they performed it. In effect, what I want to make sure everybody understands is that failure is inevitable. There is no way, in the context of cloud services, which is what I focus on inside TWC, that we're going to avoid it. It's simply inevitable. What I want to make sure is that everybody understands the approach that we're taking to reconcile this inevitability of failure against the fact that we're supposed to produce always-on 7x24 by 365 services. And with that, let's talk a little bit about what I characterize as A1 risk. Guess what, amongst those of you in the audience, what I'm referring to here? And it's not the steak sauce. Section A1 of the paper, above the fold. Here we go. Anybody remember this? Anybody inconvenienced by this little adventure several months ago? Nope. Here we go, the Chicago Board of Options Exchange. This is the gift that keeps giving. The regulators are presently looking into this little adventure to see if, in fact, the IT staff violated tightened regulations that were enacted in March of this year. That's a big deal. It's going to cost these folks some money. This was last year's gift that kept on giving. I think the final tally was about $400 million, and they're going to be fined. And they're negotiating the fine right now. That event drove the company to seek rescue. They were acquired by another firm. Quite literally, this one mistake caused by their system put them out of business. We love this one. There's a colleague of mine that had his in-laws coming over from the UK for Christmas. He said, "Got it under control. We're going to sit down and we're going to watch a movie on Christmas Eve." They go ahead, they fire up the Xbox, link to Netflix, bang, they get nailed. This one cost them a lot from a credibility standpoint. And last but not least, here you go. You've got a network provider that is supposed to provide this capability to millions of customers. These guys are knocked off the air for an entire day. Huge hit to them. All right, let's talk a little bit about closer to home. The Rubio lunge, that's what that's known as, and you go for the water bottle like that. This is what we've contended with, and this is in the past 6 months. I love doing these tear sheet slides. I can generate one of these with stuff that's no more than 6 months old, pretty much on a whim, for the industry and for the company. There are 3 of these that I want to go explore a little bit more. The first are infamous O365 issues from last November. The reason I bring this up is it hangs off the 3, this is an example that hangs off our assertion that failures fall into one of these 3 major categories. People making mistakes, hardware failing, software flaws being exposed. In this particular case, we were dealing with capacity constraint caused by one of the AV systems, and it was a cascading failure. Wiped out the whole service. Second one was due to network maintenance. Simple activity happens all the time. We took the service off. Next one, our February adventure. In this case, we were once again dealing with a latent software flaw exposed by virtue of a bunch of machines failing, as we expect them to in a cluster, the machines being addressed by the folks in the data center. They deal with the issue. Software places them back into the cluster. They were brought back in an unprotected mode. We failed from the active controller from primary to secondary. Part of the house cleaning is it looks at all the hosts, sees these as undetected or unprotected, proceeds to format them. The rub was every single one of those was active and had data on it. 66 hours later, after a lot of very careful, methodical validation, we recovered all that data. 66 hours were impacting customers. Last but not least, this one was a real kick in the shins. You go, oh, interesting. What's the issue in the facility? This was facilities maintenance. So we got the exhaust fans that we're contending with. This is managed by the provider of the building itself. They're upgrading the firmware and proceed to shut down all of the heat rejection infrastructure in the building. Temperatures spike. Wild guess what we measured is the temperature at the exhaust in some of the equipment before it thermaled. Wild guess. 170. Let me ask a question. What do you think survives in an environment like that at 170 Fahrenheit? That's right, nothing. What was interesting, I'll say it's interesting, might have been kind of painful for the guys that were having to deal with it. When they looked at the physical layout of the service in the racks, they found that they had the app controllers located higher in the rack. The heat concentrated there. Those machines were the first to thermal. The rub was that it left the storage subsystem in an indeterminate state. It took us 16 hours to recover from this little adventure, despite the fact the facility guys recovered within an hour. Hardware failure. So I talked about a person making a mistake. We had another issue with latent flaw in the software being exposed to it because of an environmental condition, failover of the active from primary to secondary, and then we've got our hardware failure. In effect, what we realize is that there's this continuum of failure modes that we're dealing with. You got all this stuff over here on the right, or on the left, I'm sorry, that's common, it's frequently occurring, and that's what I've been talking about. The well-intentioned, technically competent administrator that simply issues the wrong command on the right target or the right command on the wrong target. Hardware failures, constantly dealing with that kind of issue. To the rare, although I'd argue in this particular example, get the little red dot to show up, I'm starting to think this is sliding in this direction. Certainly my colleagues from the security team within Trustworthy Computing believe that this is in fact ending up becoming a rather routinely occurring issue. We've got our little adventure off the coast of Egypt. How many network providers plan to have somebody swim a few thousand feet off the coast and proceed to try to sever their undersea cable. It's exactly what happened. Do you plan for it? So the other point that I want to make here in terms of this continuum, and it really forms the crux of what we were dealing with failure mode and effects analysis, if we concentrate on dealing with these frequently occurring issues, what we end up with are a set of protective measures that help blunt the effect of the infrequent, difficult to predict, black swan type of events. In effect, what we had to do at Microsoft was kind of go through this shift in terms of focus. Let me ask a question. How many of you believe that your production facility looks like this? Pristine, well-maintained, tightly controlled, largely something that is predictable and dependable. Anybody? The rub is that when we're sitting in the design phase of the software development lifecycle, this is precisely what we expect as far as our environment. Nobody's going to make mistakes. The dependencies that we take are going to work 100% of the time, and we're never going to experience hardware failure that's going to result in the loss or degradation of capacity. And the simple fact of the matter is that's not true. The reality is it looks an awful lot more like this. The rub is, not only is it very unpredictable, some would say maybe even hostile, but there's a lot of uncertainty associated with this. Think about it. Rusty piece of metal laying just beneath the surface of one of these little potholes. You drive through it, bang, now you're dealing with the flat tire. That is the reality of any cloud service provider's production environment today. And anybody who begs to differ doesn't truly understand the nature of their environment. That's really what I want to make sure that I'm trying to drive home with this point, is that, again, what we have to do is be prepared to contend with the unexpected. This is something that we spent a little bit of time talking about, this notion of the drivers around availability and where our focus has been. Traditionally, I think as an industry, we've spent a lot of time trying to avoid the failure, stretch that time out between them to the extent that we can. In a practical sense, though, what we really need to focus on is dropping time to recover. Anybody familiar with the Berkeley-Stanford collaboration that's now probably 12, maybe 15 years old, called the Recovery-Oriented Computing Project? Anybody heard of that? So there's a couple of professors and a bevy of researchers, and what they realized was that we were focused on the wrong thing. We needed to spend more time on detection and recovery. And they said, look, you end up getting about a 10-to-1 bang for your buck improvement if you focus on recovery. And so that's really what we're doing. And of course, when you start to think about shared infrastructure like Azure, we have to worry about the percentage or portion of the capacity that's being impacted by any specific flaw. So the Azure team calculates availability according to this formula. And what they learned, painfully I might add, is that we really needed to start focusing on how frequently particular failure points were being exposed, how long it was taking to recover from those particular failure modes, this notion of fault isolation. In fact, it's a design criteria with the underlying fabric. At no point in time will there be any greater amount of capacity impaired by any flaw than 0.05%. At any time, for any tenant, on any stamp. And then, by virtue of focusing on these areas, the intent is to actually drive that availability figure up. But again, I go back and say, we've got to really, while we aren't going to take our eye off this ball, the focus really needs to be here. And if you haven't spent time kind of looking at some of the rock collateral, I'd take a look at that. I believe that's a reference that we make in the white paper in one of the footnotes, isn't it, Sean? Great. All right. I'm going to interleave a couple of tales of woe, only because I think it'll help kind of cement some of the things that we're talking about here. Before joining Microsoft about 2.5 years ago, I ran the production environment at Yahoo. So I'm going to interleave a couple stories that are now sufficiently dated that I don't get in trouble talking about them, because I think they kind of drive some of the points home around this need to accept the simple fact that failure is inevitable. December 31st, 2005. New Year's Day. Sounds like any other. It happens to have been a day that we added a leap second. This doesn't happen with any degree of regularity. In fact, it's somewhat random. The next one after that was 2008. We did it again this year in 2012. And it varies whether they get added on June 30th or they get added on December 31st. Now think about it. From a RDBMS clustering standpoint, I don't have 1,000 milliseconds to screw with in terms of my synchronization. We're playing clock drift in single-digit milliseconds. What happens when half my environment behaves correctly and half of it doesn't? Chaos ensues. On this particular day, December 31st of 2004, getting ready to roll to January 1st of 2005, I had 36,000 hosts panic because of a bug in the particular Linux distribution that was being run to serve Yahoo search. 36,000 devices tipped over, panicked, and were left in this catatonic state. So here you have the administration team having to now contend with the fact that they had 100% of the capacity for search go offline. The machines required either physical manipulation or people going in on the jump boxes and then basically kicking all of the power strips to get the machines to cycle. It was not a particularly pleasant evening. The moral of the story is, in the context of failure mode and effects analysis, you have to be wary of the infrequent. In terms of something that happens with a little bit greater degree of regularity, no less impactful, DST. Federal government changed when it occurred several years ago. Happily, that turned into a non-event for most companies, but it was because we invested so heavily in testing to make sure that it was going to work correctly for the very same reason. If half my cluster misbehaves, the other half behaves the way it's supposed to, the whole thing's offline. Now, I found it kind of humorous when I saw this initially, but we kind of blew out and really looked at what an outage decomposes into. There are instances where we simply don't know that something's gone into the ditch. But what I thought was fascinating was this term that Jim Metzler coined, this notion of declaring innocence. Not me, right? So think about it. In your own experience supporting 7 by 24 by 365 services, you engage the engineering team, and you're now trying to triage the situation. That is a serial process. Rarely is it ever executed in parallel. Now, of course, one can argue, and of course Jim was a networking guy, the network is guilty until you can prove it innocent. Sad, but true. I'll ask a question about that in a minute. Or ask you to give me your best guess on, in percentage terms, how much of the time the network really is guilty. The rub is that we need to attack the highly serialized nature of having these various teams proving beyond a shadow of a doubt that it has nothing to do with the particular piece of the infrastructure that they support. Tale of woe number 2. This was November 26th or 27th, 2007. Cyber Monday. Yahoo Merchant Services. We'd worked furiously all summer and well into the fall to produce brand new shopping cart and checkout functionality. We had the old, we had the new, and we'd done a bang-up job advertising this to the 40,000 merchants that used this service. Extensive testing, so we thought, and a fair number of the merchants had migrated. But we still had merchants that were running using the old checkout functionality. So think of it as kind of shopping cart 1 and shopping cart 2. The morning of the 26th, about 8:30 Eastern, lo and behold, we start seeing alerts in the knock. Latency's beginning to climb. We're starting to get a lot of calls in the call center from merchants saying people aren't able to complete their purchases online. Like, what in the heck? We've been testing this for months. We've got a lot of merchants on both of these services. What we found was that while we had effectively estimated appropriately for the capacity for the front ends, they were both converging on the same persistent store on the back end. What complicated matters was that we had queries that were behaving differently between the two services. So the triaging was protracted. Busiest online shopping day of the year. Total online shopping that year exceeded $750 million. Yahoo stock closed down 17% that day. Tell me that reconciling your engineering practice around this basic principle of failure being inevitable and that you really do need to think about what you may think is the unthinkable and factor that into your design isn't important. Tale of woe number 2. So, failure mode and effects analysis. In Microsoft parlance, we call it resilience modeling and analysis. The rest of the world thinks of it as failure mode and effects analysis. The key thing here is the fact that it's repeatable. I'm not interested in this being a one-shot exercise that my design teams go through inside each of the product divisions. I want it to be done with a high degree of repetition, but I've got to make sure that it's fairly lightweight, because the fact that we're evolving and we're seeing far more teams moving toward an agile process means this has got to be pretty doggone lightweight for it to work. This is a design-oriented exercise. Come back next year, we'll talk about fault injection, because that's where we're heading. But the simple fact of the matter is I got to get the teams to design to deal with that first. All right. So I want to talk a little bit about what we see as the primary benefits associated with adopting RMA, resilience modeling and analysis. The first is that we're moving away from this notion of the pristine production environment, all dependencies working all the time, and nobody screwing up, to the fact that you're going to look at each and every one of these in a structured fashion and determine how it can possibly fail. You move toward recovery as being your primary objective because you are now assuming that the failure will take place. 2, we want you to focus on the normal, the frequently occurring. Do not think in terms of the edge cases. You recall the earlier slide where we were showing all of the frequently occurring things that you cope with fault tolerance measures versus thinking in terms of BCDR on the right. We'll worry about the edge cases. You'll get to that, but focus on the frequent. That's what we're dealing with here. In effect, the outcome of this is simply a way that you can predictably prioritize the engineering investments that need to be made, as opposed to it being done reactively when the service is deployed. You're doing this during the design phase and trying to squeeze a lot of the sin from being committed later. Again, the focus is on detecting quickly and recovering in the shortest possible amount of time that we can. We talk a little bit about that when we get to the math associated with the worksheet. You end up identifying, in very precise terms, specific monitoring and telemetry requirements that make their way into the design spec. Again, it's not an afterthought. So we actually focus on this notion of detectability, and there's a weight associated with that, and that could, in fact, in some cases, depending on the design of the service, result in work items being created that get captured in the last phase of the exercise. And lastly, as you conclude this exercise, you start to think about what those coping mechanisms are going to be that you're going to incorporate into the service itself. This isn't meant to focus on snapping to how you're going to solve the issue, but you do broach that particular topic during the process itself. We break it down into 4 phases. Pre-work being the first, and an extremely important one. We're going to delve into this a little bit more deeply in a moment or two. Followed by this notion of this discover phase, which is where you're really cataloging all of your failure points and your failure modes based on the work that you did during the discovery phase. The next phase is really performing the assessment against each of those discrete interactions and the failure associated with it to determine whether or not it is higher risk or lower risk related to all the rest. And then lastly, we call out some very specific activities that need to follow the exercise in order to make it worthwhile. So I'm going to dive down into each one of these a little bit more. The first thing that we do is we create the component interaction diagram. That's what we refer to this as. Anybody familiar with the SDL, the Secure Development Lifecycle at Microsoft? Have you implemented it? So you realize, if you think about how that process works, early on you go through and create your DFD. You identify where those trust boundaries are based on that. Oftentimes people are using the DFD as their basic model. There are aspects of the component interaction diagram that are very similar to the threat model and the graphical depiction that comes out of that. So in some respects what we're trying to do is draw parallels between something that we find is familiar among many, many design teams and extending it into the reliability domain. So think threat modeling in the context of security. This ends up being what many people might think of as a fault model in the context of reliability. We'll talk a little bit about some of the visual cues that we've created here too. For example, calling out specifically where you are relying on SSL. This has proven to be a very, very popular, unfortunately, popular source or frequent source of failure in the environment. So what we've done is incorporate that visual cue into our template to try to facilitate a conversation around that, as opposed to it being something that one of the folks in the feature crew that you have as you're facilitating this session need to think up on their own. Another popular one that we find, throttling. So we cooked up this notion of the yield sign and really trying to flag that. And we found, based on the pilots that we did, that a lot of teams appreciated having some notion of what the SLA was associated with that dependent service that they're calling. So when you can capture that data, let me see if I can get it here, we encourage folks to incorporate that information as well. Next, this notion of caching. It can be your friend, but it can also prove to be a bit of a problem, particularly when you're dealing with cache that is now stale, cache that is not performing well, cache that's been poisoned. You got to think through those. But again, if we don't provide the visual cue, oftentimes it's something that the design team, particularly when you're dealing with early stage thinking, it won't immediately come to mind. And what we're trying to do is structure that thought process. Last but not least, Retry logic. What are the assumptions that you're making about the way that you're approaching that? Is it 3 strikes and you're out? Or are you being a little bit more intelligent and maybe incorporating an exponential back-off type of a mechanism? Depends on the criticality of you getting back a response to your request. But again, if you're not thinking about it explicitly during the design stage, it's often easy to make a bad assumption that manifests itself in a really crappy way when the service actually deploys. A couple other points that I want to make about the component interaction diagram. One, this notion of the component, the interaction number. This feeds what you do as the second step in this process. So this is step 1. We've had teams that have spent maybe 40 hours during the pre-work phase generating this, iterating over it time and time again until they get the document to the point where they believe that the schematic accurately reflects the way the service works. We've had teams tell us that they were willing to stop after just this phase, that they had extracted enough value from just getting all the relevant people in a room and hammering out how the service was going to be bolted together. Of course, we encourage them to continue beyond this point, but what we're seeing is that there is a high rate of return on this preparatory work. So again, the interaction numbers are important because these get mapped into the worksheet that drives the subsequent phase. The notion of fault domains. This is something else that we like to see teams explicitly call out. In this simple example based on our Contoso organization, you can see that we're looking at taking the total number of instances in this particular case and dividing them into these 5 fault domains, implying that there's probably 4 units of capacity associated with any one fault domain. This is a huge point that we want to make sure everybody understands, and we go into some detail in the white paper about this. The other thing that you want to take away from this particular example is we really don't depict physical infrastructure. In fact, we encourage you not to do that. Now, this can be applied to what we might characterize as a traditional implementation where the physical infrastructure matters quite a little bit to the design team. But in this particular, and it applies, we've applied it successfully to a number of those legacy services at Microsoft. But in this particular example, we encourage the team during that early stage to avoid starting to head down that particular rabbit hole. Let me see if I've covered all my points here. Okay, I did. All right. All right. Let's move on to the second phase. There's the sort of theoretical approach that I depict on this first series. And what we do is we ask the teams to think through, in this order, the nature of the failures for each of the interactions that they've captured in the worksheet as they transferred off the schematic into what we call the resilience modeling and analysis worksheet. The first is whether or not the resource that you're requesting is even there. And what we've seen is oftentimes the design teams will make assumptions around, well, of course that request is going to be there, or that resource is going to be there. So we encourage the teams as they're going through the session to think about their failure modes or their failure points in this order. 2, bad auth. Is the administrative account, what happens if the administrative account is missing? What happens if the certs have expired? What are you going to do if you aren't able to authenticate appropriately? 3rd, what happens when performance begins to degrade? When you start to see latency climb, when you start to see timeouts, and so forth. Is your system capable of dealing with that? Next, just simply getting back the wrong thing. You did not expect the result that you got back. How are you going to contend with it? Thinking through that rather carefully. And then lastly, what happens if you start to see capacity being taken offline? What's this going to do in terms of queuing mechanisms and these exponential back-off mechanisms that you put in? So I said, okay, great, we've got these graphical representations. Why don't we present this very same thing in a way that might be a little bit more resonant with the audience? And so we started to think in terms of how can we really make sure people understand they have to think about something simply not being there. Then we move on. Okay, it's there, but now I'm having difficulties with my authentication mechanism. Okay, what's that due to? What am I going to do about it? What we're focusing on are those failure modes. When I'm dealing with latency, what if I start to see in these infrequent timeouts or intermittent timeouts? There is something just fundamentally wrong about that poster. And then lastly, of course, when we start to deal with reduced capacity, what's that going to look like? We move on to our third phase, rate. So this is the first time you're seeing the actual worksheet. And I want to spend a little time talking about how this is divided up. The things that we want to do is, of course, capture that component interaction number. We look for a way to quickly tag these and group them together. In this case, you see it's sort of the requesting entity and the responding entity that we captured. Where's my little magic there button? Give them a short name. We describe it a little bit more fully, and then the specific response that you expect. This middle section here in the spreadsheet is where we introduce that notion of the effect of the failure. So think about the left-hand side of this really being the way you describe the interaction and the nature of a discrete failure. This portion over here toward the right is where we're talking about the effect of that failure. Is it significant, insignificant? And there are drop-downs that you'll see characterized, that we go into a little bit greater detail in the white paper, that characterize sort of these basic ranges. Because what we're trying to do is to get to this relative risk rating that's going to now cause this far right column to sort. And that's really what this is all about, because this is when we start to move toward deciding how we're going to prioritize those engineering investments. So the sequence of this changes as a result of going through and establishing values. What's the effect that that particular failure mode is having on your customer base? How much of your customer base is affected? How easily detectable is that particular failure mode? Remember, in some cases, you're talking about a dependency that may be multiple steps removed from your core service. And so you've got to determine, while it may be something that is clearly going to have a profound impact, you may have a heck of a time detecting it. Lastly, recovery targets. How quickly do you think you can restore the service from that particular failure mode? And then, of course, likelihood. And it is a combination of these attributes, these 5 attributes, that result in a numeric score that then we tag visually, and then you've got the ability to actually sequence those. And you can see how we're talking about, in this particular example, that you're dealing with a major impairment of functionality, or you're affecting a significant portion of your customer base. It's likely to occur, and we may end up with cases where it's rather difficult to detect. And that's going to drive the relative risk up, and those are going to end up higher on your list. We take what we learn in this particular case and then move on to the final step in this process. And we've really broken this down into 4 discrete activities. The first and foremost is file the bugs. We've got a great story about one of our pilots. So we're in the heat of battle. I'll back up to this, so we're staring at this again. So we're in one of our facilitated sessions. We got the complete feature crew sitting in the room with us. We're going through and systematically tackling each of the failure modes. We see the dev lead kind of quietly pivot away, and we start here and type. It doesn't register initially, probably go several minutes. And we're like, hey, for the sake of argument, we'll call him Bob. I said, hey, Bob, what are you doing? He said, filing a bug. I said, well, what else are you doing? I went ahead and checked the code out and fixed it too. So they've got the bug filed for test coverage. In this design review, he goes ahead and had identified an issue and dealt with it in real time. Now there's agile and then there's really agile. I thought that was really agile. Now, I thought that was a great example because we were dealing with something that never made its way into the production environment, and Bob was convinced that that wouldn't have been surfaced until it had gone into production. So we're heading off future problems. So, record the bugs. 2, implement the fixes. Part of the value proposition that we have to make sure that the teams that we're asking to adopt this understand is you're only partially fulfilling the promise if you don't resource all the demand that you're creating by identifying these new incremental requirements associated with contending with the failure modes of your service. If they aren't being assigned, if they aren't being tracked, if it's regarded as an adjunct process, I can make the strong argument the technical debt associated with your service will continue to accrue because none of those things are going to make their way above the keep cut line. So we're very explicit about asking the teams to assign the work items that they've created and make sure that they're tracked. Next, validation. You heard me describe this notion of test coverage. And this is where we start to cross over from failure mode and effects analysis to the corollary in the reliability space that is often identified as being similar to pen testing in the security domain. And that's fault injection. Test in production. It goes by many names. The important thing is to make sure that you've got the ability to validate the effectiveness of the coping mechanism that you have now factored into your spec and that you are proceeding to resource and develop. You've got to make sure that you have the appropriate validation mechanism. That could be in the form of instrumentation in the service itself. That could be in third-party monitoring that is pointed at the service. It's capable of being solved in many ways. The simple fact of the matter is we want to be very explicit about calling that out as a discrete step in this final phase of FMEA. And lastly, this is a rinse, lather, and repeat exercise. I want to pause and spend a couple minutes talking about time estimates here. We've had teams, as I said, we had one team spend 40 hours iterating and iterating and iterating on that component interaction diagram. We've had teams that have made their way through the 4 phases, the pre-work, all the way to the point that they have coded and deployed those fixes inside an agile development cycle. And we see those typically averaging 2 to 4 weeks. So this is incorporated inside of that. In terms of the facilitated RMA session, the resilience modeling and analysis session, we see the sum total of that generally taking somewhere between 6 and 8 hours. Now there's an important point that I want to make about the careful analysis of the RMA worksheet or we're looking at those discrete interactions and we're assigning the likelihood, we're trying to assess the percent of the customer base that's going to be impacted, how detectable or recoverable that particular failure mode is. We found if those sessions go over 90 minutes, the productivity tails way off. It's one of the points that you'll see flagged in the white paper, and I want to emphasize that here to those of you that are in the room. If you end up with a marathon session on your hands, cut it off. As the facilitator, say, we're going to time box this to 90 minutes. We will get through as many of those interactions as we possibly can, then we will schedule more time. Now, based on the pilots that we've conducted, it's taken no more than 3 of those to get through any service that we've partnered with. But that's a real critical, and something you might not initially recognize. But if you pull that feature team together and you think you're going to grind through this in one single contiguous session, and you're dealing with a complex service, I would advise you to think in terms of splitting that up. So, in many respects, the way I look at this is if you plan for failure and you've incorporated those coping mechanisms, you end up in a situation where things actually just work. I do want to open it up for questions, but I think I got a couple of housekeeping slides that I need to move through. So, I would encourage everybody to take a look at the TWC blog, Microsoft.com/TWC blog right there in the middle of the page. You'll find links out to the reliability page there as well, with links to the white paper as well as the example templates and stencils that we've created and made available for the public. We partnered with the Global Foundation Services team. It's responsible for all of Microsoft's computing footprint worldwide. And we did a 3-part series that was published earlier this spring. I would encourage you to go out and take a look at DCK. It's wide open. We did another one for DRJ, but you got to register. So take a look at the DCK series and see what if there's some relevant information that you can extract from that. In terms of track-related resources, again, I would strongly encourage you to take a look at Microsoft.com/TWC. In addition to a whole host of resources that you'll find around our security and privacy pillars, you'll also find a growing body of work around this third pillar that we've invested rather heavily in for the last 2.5 years now around reliability. We've got our TechNet resource slides. And last but not least, scan tag for the evaluation. All right, so I will pause and open it up for questions. Come on, you got to have some questions. Maybe I'll task everybody here with a go-do. I said I was going to ask a question. We'll play closest to the hole, and you get one of our awesome T-shirts for it. Wild guess about, in percentage terms, maybe it'll be an educated guess. How much of the time is the network proven to be the culprit for an interruption in service for cloud-based services? 3%. I'm sorry? 32%. We did a study, and we've confirmed this looking at data, understanding that I get to look at inside the company data. A little bit harder for me to get that same level of fidelity in the data that I'm looking at that's publicly accessible, but we've seen these two numbers end up plus or minus 3%. 32% of the time. In percentage terms, how much of the time is the issue due to the introduction of change into the environment? deliberate manipulation of the production environment in percentage terms. And that's determined as the trigger event that leads to the interruption in service. Educated guesses or wild guesses? So I'm hearing well in excess of 50%. Turns out that it's 40% in our study. In our study, 40%. I thought it was higher too until we started digging into the data. Now, if your experience is that you're seeing this very high level of correlation between the introduction of change and the subsequent interruption in service, I'd make the strong argument that this process that we've described will be of great value to your engineering team, because you're going to force that group, the feature group, to sit down. When I'm saying capital E engineering, I'm referring to all disciplines. So I'm going to dev, test, your operations team, service engineering team. They go by many names. This process, rigorously applied, will compel your engineering team that's responsible for that service to think through those specific failure modes, and then, as a logical next step, they think about the coping mechanism. What's the risk mitigation approach going to be to dealing with that, as opposed to assuming that the dependency that we're taking on the network being there literally 100% of the time, or that surely our production computing facilities, the data centers, can never be taken offline. And we saw some examples where we've pretty much proven that that's not the case. When they're forced to confront these inevitabilities, then you're unleashing the creative ability of that engineering organization on developing the coping mechanism that's going to effectively blunt the effect of that failure, which will happen, from the customer experience. And that's sort of been the what I would characterize as approach that we've been evolving toward as a company at Microsoft. Accepting the fact that these failures do occur, that they are unavoidable, inevitable, and that you merely need to cope with them in a highly effective fashion. As I said, this is the first step from an engineering process standpoint. We're moving toward how we will now transform that from a tooling standpoint into aids that we'll be able to equip our engineering team with to facilitate deliberate programmatic fault injection on a go-forward basis. Question?
So earlier you mentioned key failure points for people, hardware, and software. Do you have percentages on which those happen? How about the A1, general failure?
The question was, have we broken down those three uber categories of failure in percentage terms? And the short answer is no, we have not. What we did is we took a sample set that I think it was somewhere in the order of 1,000 discrete incidents, and we were simply looking to see if we could categorize those failures in a meaningful fashion that would drive the analysis, knowing full well that if we were to look at the way that in percentage terms, that small a sample set could prove to be anomalous. So we didn't pursue that or publish that in our findings. If I think about people making mistakes, I could draw a parallel between that and the introduction of change, and saying, well, gee, there was something that was overlooked in the planning process around this change or in the execution, and there may be some correlation there, but I think that's a bit of a stretch. Yes?
How are you reducing
That is a great question. The question was, how are we at Microsoft reducing our mean time to innocence? The way that we're doing it, and we're finding that it's proven to be highly, highly effective. The traditional bright red line that existed between your development discipline, your test discipline, and your ops discipline, these are now being blurred, if not eliminated entirely. If I want to use the, I guess, popular catchphrase, DevOps, that's really what we're talking about. And we've seen this has proven to be highly effective. Making sure that those that are responsible for producing the product, qualifying the product, and operating the product, substitute the word service if you want. They understand that that is a shared responsibility, and that, in fact, when you check the code in and you say, I'm done, that is not where the developer's responsibility ends. In fact, we've had teams that have eliminated those distinctions organizationally so that they're now dealing with a single engineering function, and you merely have individuals who may specialize in a particular act inside that function. So you'll have people that are developing, people that are testing, people that are operating the service. But it is a shared responsibility, and they are graded on the quality of the service post-deployment. That's the way that we're tackling that, as opposed to, well, I've proven it's not me, and I really don't care if the service is still down. What I care most about is that it's proving that it's not me, so I'm out of the line of fire. And I think that's consistent with some of the contemporary writing and thinking and talking that you've heard from luminaries like Gene Kim and his counterparts, Patrick Dubois, around the DevOps movement. That help? We're doing it, but we're not doing it in what I would characterize as a highly automated fashion. What we are doing, and this is, again, around raising that level of awareness, we're taking examples of interruptions in service, outages, and we're working with the team that was responsible for stepping in, triaging, and resolving it. We're abstracting lessons learned. We're publishing them across the company as case studies around the lessons learned from our service outages. So it's sort of a brute force mechanism, but we're finding that to be highly effective as well. In fact, the distribution list that we used when we started this a mere 90 days ago has grown by over 50% with the first 3 case studies that we published inside the company using this mechanism. We've had a huge uptake in terms of the number of people that have expressed interest in wanting to learn more. And the intent there is to kind of leverage the tough lessons that Team A has learned managing an outage and make sure that the same underlying issues aren't lurking in other services as well. So it's not an automated way. We're not leveraging tooling at this point. That said, we talked about the creation of that component interaction diagram and how that closely relates to the threat modeling activity in the context of SDL. We're working with the team that's responsible for the threat modeling tool and extending it such that we'll now be able to generate at least an early version of the fault or the component interaction diagram and flag potential failure points or failure modes using the same underlying tooling. Yes? This is really important, not important. Affects everybody, will affect no one. The guidance that we provide to the facilitator, the person that's responsible for moving the session along, is, and this works with the maturity modeling that we do as well, is that if the facilitator starts to see the conversation going sideways, that they ask everybody to pause and they ask the team to think conservatively and make the call. So rather than trying to gain consensus, they're kind of asked to step in and kind of cast the tiebreaker vote. And as the facilitator, they're expected to rate conservatively. That means when in doubt, if you're trying to decide if it's over 50 at the courses level or under 50% of your active customer base that would be impacted maybe by a particular failure mode, if they're on the fence, you say, rate conservatively, over. Because what it'll do is it drives, the conversation will then turn as you move toward what that coping mechanism is going to look like, and it may sharpen some of the team members' thinking in such a way they can go back and say, okay, we now all agree, rather than having to have the tiebreaker vote, it really does affect the majority of our customers, and we've thought through how we're going to deal with it. So use the facilitator as the person to kind of contain that circular argument and make the call.